My name is Jeffrey Yang. I am a senior architect and manager at Intertech and a building enclosure commissioning professional. My colleague here, a fellow presenter, is
I'm Stephen Seller with MIT. I'm a turnover and commissioning manager, mechanical engineer by education, and learned the building enclosure on my own through studying and reaching out to the community. So thanks for coming this morning.
Steve is unique in that he's one of the few individuals that's highly proficient in both building enclosure commissioning and mechanical commissioning. So his knowledge on both fields helps to bridge the gap between the two disciplines.
It helps. Sometimes it hurts, but.
Right.
Again, CX Energy, don't forget to check them out and earn the credits for continuing on. Again, like I said, this is AIA. Education credits are available, so just check in, and I think you get the credits like that. And then I think this is going to be online, and you can answer some questions and get the credit that way as well.
So we'll be talking about creative. Can you go back to this title slide? We'll be talking about creative enclosure test methods. And how many here are involved with building enclosure commissioning? Quite a number of you, fellow allies. That's great. And how many are involved with more with mechanical commissioning? Any? Oh, great. Oh, I hope you will enjoy this presentation because we will be also doing a brief overview of the building enclosure commissioning process. So what do you do when a client asks you to test a unique awning assembly where there are no known test protocols available? How do you test a large prefab panel? And even though the lab is hundreds of miles away. And how do you transform a visual mock-up into a fully functional test mock-up? How do you assess the performance of an existing masonry mass wall? Those are the examples that we will be reviewing with you and sharing with you today. So building enclosure commissioning is an important quality assurance plan to assure the performance of our state-of-the-art wall assemblies in terms of weather protection, energy performance, as well as structural performance, and to assure and enhance user comfort in terms of environmental, sun control, and acoustic isolation. Building enclosure commissioning also can help reduce costs. It can help reduce costs by avoiding post-construction repairs, minimize or simplify periodic maintenance, and to assure the continual operation of the building. In an aspirational goal, building enclosure commissioning aspires to collaborate with the owner, architect, and construction team to design, build, and maintain long-term durable structures that have 50 to 100-year lifespan and can reduce embodied energy by being able to be adapted for reuse after it may have outlived its original purpose. So next.
Yeah, and for us, it's super important that the buildings are made to last a long time. We have buildings on campus that are over 100 years old, so our standards are pretty high. We are fortunate enough at MIT to be able to afford testing and specifications, and we're committed to doing building enclosure testing, so I'm kind of fortunate. I know that's a big push in the industry, but it's important for all of us who do it and who are involved to stress to the clients, people like me, how important the testing is, and make sure that you put away or talk about getting money to do the proper thing. So a lot of what we're going to talk about today is how to strategically insert ourselves and stress the importance. So it's kind of help out everybody who's gone through it. I feel fortunate enough that where I am, I'm in a good place and I've learned a lot. So I wanted to try and help people understand, and if they could avoid some of the pitfalls that we made, that's what this is all about from my perspective. So Jeff's on the technical side, I'm on the practical and what we get out of it. So
We always have good dialogues together on our projects.
So yeah, so talking about what we do. So I put together, our group puts together an RFQ for consultants. It's not always certain. I use a lot of different companies, but our plan is, our request for proposals is pretty detailed to the point that, you know, we're looking at it and we're actually giving in this table which has the test that we think the project needs. So every project, we'll go through it and review what's unique about it and what types of tests and quantities. So this way I'm able to go out and get pricing from different vendors and compare apples to apples. And I always leave out, hey, if you don't think that what is here is appropriate, write it in an appendix somewhere, but I want the price so everything's the same, so I have a baseline to compare it to. So that goes a long way as far as justifications and things like that. At the end, we always, not always modify it, but it helps us baseline everything, so it's easy for me to bring to my management and to the project managers internally to get it approved. So we find that this is helpful, so it's something, we go to the point of defining how many tests, what the test criteria is, if I know it, or if we know it. Sometimes we don't, so then we highlight it and go, hey, we think this is the appropriate test. One of the things that I was shocked about in this industry, coming from the mechanical side, was I took the courses to get certified as a building enclosure commissioning agent. And I went out there thinking, okay, I'm going to learn what tests I should ask for. I found out that there's 500 tests. And if I do all 500, we're not going to build a building. So it was mind-blowing to me that the industry doesn't just say, you know, for a window, do this, for a store, you know, there's all these tests and, oh, you can do them. There's all kinds of standards and things like that. But, like, what are you getting? Like, so it took a long time to figure out what tests are the best bang for the buck from my perspective. So I think, you know, this helps a lot define it. And then we go through and give a table again of the criteria that we think. And we always shoot for the highest criteria possible and leave it up to the design engineers and the contractors to say, hey, we can't test at that number. And we go, why? And they kind of explain it. Usually they say, oh, industry lets us. And we're like, well, that's not a good excuse for us. We're not going to accept that. But if there's a component that won't pass at 15 PSF, we'll reduce it to what it will pass at. We don't want to break things, and we don't want to come to the test knowing that it's going to fail. But we don't want to make it too easy to pass either, so it's a fine line sometimes.
I just want to say MIT is one of the most demanding clients that I've worked with, and but they also provide one of the most detailed and most robust RFP that I have encountered in my career, and it really helps to start the building commissioning plan right, because you already have a very detailed start. And I've worked with MIT for a number of years, and I have seen how high the bar is that MIT sets for us to pass. And it seems like every project I work with you, Steve, the bar keeps getting higher. So, but we're still managing to get everything to pass.
The designs get more and more complicated. They make bigger glass, and
that's right.
They want it. They make whatever. It's crazy. So another thing that's completely different from traditional MEP commissioning is the time frames and the durations of tasks associated with building enclosure commissioning. I tried to put together a little timeline. We have something like this for MEP commissioning. I threw together one for building enclosures. But the thing that's most noticeable here is that a lot of the building enclosure aspects and steps happen early, like real early. So it's really hard to get a commissioning agent to do both building enclosures and mechanical, because you need them. Sometimes it's 2 years ahead. You need building enclosure people online, and you don't even have a design for mechanical. A lot of the times it's like, oh, we think we're going to have fan coils. How many? We have no idea. So how do you price that? So it's really hard. So I think it's important to educate the owners who want to have one commissioning agent do it, to stress to them how early you have to be on board. Because if they do traditional MEP commissioning, you guys are going to be late, like really late. You're going to miss all the important stuff where we get the most bang for our dollar. Is all in the green in the design phase. Doing the specifications, working with the design team. A lot of the building enclosure projects now are design assist, which makes it even more complicated and more important to have a consultant representing the commissioning on it, because you leave it to the consultants, they're just going to do what they did on the last job.
Yeah, we generally get involved early on, even in the review of the owner project requirements, and we proceed there to peer reviews, submittal reviews, and of course involved in the construction phase heavily, and all the way to the post-construction phase in the well over a year after the project's finished.
Yeah, so for us, the most important thing is helping with the mock-up and or factory testing. It's a critical step, and that's the primary focus of this presentation, is about that step right there. To plan for it, to figure out how much it costs. It does cost a lot of money to do, but it's invaluable if it's done right, and we should all strive to do it at some capacity. And we're going to go through some examples as to what you can do if you can't afford the ultimate mock-up. And then obviously, then you got to build it and then test it. And it usually happens early on in construction, before it's on our building, whether it's on at the factory or off-site, or even on the building if it has to be. But you should try and get that done. And it is a huge cost, but it's a critical step for us, as you'll see from our examples. Sure.
Are you getting involved in monitoring weather during installation of components?
We definitely do. We
Yeah.
definitely do. Weather affects a lot of components, especially those that shrink and expand, and that's an issue. Of course, the issue whether or not it's wet or not is going to affect how if you even can install some of your components. A cold weather condition is pretty challenging. We have built under cold weather condition, in fact, almost all the time up there in
I think
Boston.
one of the examples here is a mock-up under cold weather.
And we work with the contractor to make sure that cold weather condition methods are being implemented, whether it's the way you put on the membrane or even in the performance of tests. Last thing you want is you turn on your water spray and you're just spraying icicles on your mock-up. It might be a pretty sight, but it's not good for your test equipment. It's not good for the test.
Yeah. No, and I use weather a lot on campus when the buildings are being built. After every storm, I'll walk all our new construction buildings before they're finished to have an idea if there are problems. So even without my consultant over there, I can walk around and see if water's in the building and know if the skylight's leaking and things like that. So sometimes I try and use weather. Our projects are usually pretty long in duration, that we get one summer and one winter in there. And so we make sure that there's a plan in place. I try and use that a lot, actually.
It actually rains and snows a lot in Boston.
It does. Yeah, so that's a quick overview. And I think all these slides are going to be part of the handout. So again, looking at mock-ups, and that's the primary focus. So ideally, you want to work with the designer and figure out how big. We've learned from experience that half-size mock-ups are great, but full-size are much better. You get a realistic idea of what it's going to take to build it, and the weights and the movements and things like that. So half size is good to make sure that you can build it if it's not a super complicated building, but full-size mock-ups is definitely the way to go. I know it's expensive, again, but the enclosures are getting more and more expensive, so I think it's justified to ask for fees to adequately test it. I think we have to stress that, and part of the reasons why I'm getting out there is to help the industry get to that level, hopefully. Again, it's a conversation between the design team and the owners and the consultants about what you want to test. The building's 500,000 square feet. You can't build 500,000 square feet mock-up. But you got to pick the challenges or the places that you think are going to be most challenging, or the ones that take up the most space, depending on what the building is. If it's an office building, it's one thing. You got to pick a sample, a representation of it. For us, it's a lot of times it's the unique, one of a kind in the world interface with 18 different angles and 45 different pieces of equipment. And so the mock-up does not have to be one-to-one configuration of what it's going to be on your building. So you can take a 20-foot section of a wall and put in 5 or 6 different architectural elements to test. So use that, be creative with it, and get everybody's input. The designers have, they know what they've done before and where they have problems. Have a frank conversation with them and the builders as to where they think the problems are, and put those in the mock-up. You're spending the money, don't do a simple wall, a masonry wall, and that they've done thousands of times.
One of the reasons why you want a full-size mock-up, especially if you do structural testing, it really can inform and validate the structural calculations that's been done to make sure that the exterior wall assembly withstand the required wind loads. The other thing is, as Steve mentioned, is that it should really represent all the typical conditions in the project, particularly at the joinery, because it is at the intersections of multiple components where the most often first order, pinhole penetrations occur, or linear gaps in sealant adhesion occurs. Is always at the intersection of multiple components. So yeah, it's critical that you get the best bang for your buck, and that you're testing as many representative details of the project in your mock-up.
Yeah. And also another thing to, if they push back and stuff, most of the time the architects want a visual mock-up. See if there's some way to modify that and use it. Even if it's small, start with that and teach them and show them the benefits. Because I'm pretty sure once you do one, everybody's going to realize the benefits of doing the mock-up. So even if it's just a visual mock-up that the architect and designer always want, say, hey, can we put a roof on it? Can we weather tight it and make it so you can test it? And you'll be surprised about the results most of the time. Again, a conversation about, do you want to use your mock-up as a visual mock-up? Again, we're lucky that we have some fields once in a while that we can use and do it like not on the job site, but a half a block away. And we can orientate it in the same way as the building, so they can see the reflection at midnight or 2 in the morning, whatever they want. So it's good just to have the conversations, right? So there's a lot of details, and the more people who get involved, the better results you should have. So
the last thing that I think was on the previous slide was Steve already highlighted the importance of making sure early on that the lab mock-up is in the building budget and in the construction budget. And we'll be discussing that point many times during this discussion. So we usually, during the building enclosure process, we use standard nationally recognized test methods. It's the best way to verify performance of installed assemblies. But there are times, for a variety of reasons, where test methods have to be adapted to meet project requirements. And what do you do when you have to engineer these tests protocol modifications? Well, it's not something that you just simply do casually. It is important that you define, based on the component that you're assembling, the assembly that you're testing, that you have to define what is the appropriate test criteria. It shouldn't be vague. It shouldn't be something that is not quantifiable. But quantifying is a challenge. It's something that you need to start with discussion with your project engineer, and if necessary, engage in a conversation using comparative analogies to kind of come to some resolution what the test criteria is.
Yeah.
And then once...
yeah, and make sure that the manufacturer is involved in that, because they'll always push back and go that they don't agree with something. And you know, when you ask a couple more questions, you find out that just they've never done it. That doesn't mean that they can't. So
Yeah.
Yeah.
Yeah, and you know, don't be shy with talking with the manufacturer, because that's sort of one of the points later on in the slide, is that they will be a very helpful resource in terms of advising you what can or cannot be done in terms of testing their assembly. And a lot of times they can support you more than resist. They want to know too. So it helps their marketing plan. So you have to, in researching alternative test methods, you know, you start with researching what's out there right now, what's being used for similar systems that you can apply here. And we do that a lot on our projects here at Intertech. And oftentimes there are precedences for modifications. One of the most common modified tests is the ASTM E1105, I think it is. My colleagues at Intertech can verify that. And that's done in a variety of ways, in different manners, whether it be a sloped wall or a wall where a test chamber cannot be installed and so forth. Ultimately, it's really wonderful if you can access a lab testing agency, because a lot of times they may have done the test. It's not a formal test, and it might be a customized test, but they may have done a very similar test on another project they can help you with and adapt. So that's very important to research your alternative methods carefully. And then the most critical part is, after you've done all that homework and you have come up with oftentimes not just one, but 2 or 3 different test options, you have to build consensus around the test methods and the way of evaluating it. And it has to be done with the complete OAC team. The owners have to buy into it. The architect must understand and agree with it, including their project engineers, and the contractor has to agree with it. So that way, when the test is done, it's understood that it's objective, it's neutral, it's not biased, that it really is performing what we all, as a team, the OAC team, wants, is that the building assembly as installed is performing as it's intended. So
make sure that it's in the schedule and that there's enough time to cure components and things like that. A lot of times the contractors rush to put it together, even the mock-ups, and you know, the night before they're putting up sealant, and then 5 minutes later we're blowing the sealant off, right? So make sure that there's enough time, and don't think that everybody understands it. Like, take the time to go through it with them and make sure that they understand that cure times need to be what they need to be, and don't skimp on that, because the worst thing you can do is test something and find out that the contractor, oh, I just put that in last night. I'm really sorry. I didn't think you would know. You know, it's like, so here you are, you're spending all kinds of money. That's a pretty hard one to overcome sometimes. So make sure that you ask the questions outright, and, you know, hopefully the contractors do the right thing and tell you if they're not ready, rather than, yeah, I'm afraid to say something, so yeah, we're ready. But then you find out right away that it's not. So it's horrible that I've seen that. But again, you know, I'm trying to be open and share things that help everybody, right?
it's important that we perform fair tests. I mean, Steve and I was involved with testing a project recently where we were going to test 3 curtain walls, and one of them, they were still sealing the bottom sill joint.
Yeah.
And we're not here to test to fail. We're here to test to confirm performance.
Yeah, it's easy to break stuff.
So we just avoided that one.
Yeah. Even when we don't want to break things, you'll see in a few minutes that things break anyway. So the idea of these tests are not to break components at all.
Right.
It's to test them to what they were designed for, not to do anything more than that.
Which is a great segue.
And they have a hard time passing just that.
Which is a great segue for the next slide here. Breaking things. Yeah.
Yeah, so then, the case studies, we're at the point where we're going to start showing you some examples and talk about things that we've done. So we have 5, 6, 7, I don't know how many, there's quite a few different criterias and tests that we put together now. So we'll start getting into the fun stuff. So again, simple, that was a mock-up. So it's just a standard curtain wall. Or not the curtain, just a standard wall. And this is pretty basic for us, and it should be for most people. And you'll see what went wrong with this. So again, the things that we look at, constructability. So a lot of times the mock-up is a great tool for the contractor. The designer puts it on paper and its means and methods and whatever else, and then the contractor comes in and goes, I don't have anybody that can fit there. My tool won't get up there. So it's a great time for them to learn on how to build your building.
Yeah, how it constructs can affect everything. It can construct your weatherability, it can construct your structural performance.
The timing.
It can obviously affect visual appearance too. So
yeah, even on this, we had some heat trace that's going in the gutter. So even where to put these conduits so they don't affect some of the details and make extra penetrations. So that was a big thing actually on here, was like, where does all that go? It has to be there. The architect doesn't like to see it. But at least if you do it on a mock-up, they can say, oh, can we color it something else? Or could we move it over 3 inches? Or whatever. It has to be there because it needs to work. But obviously they don't want to see it. So it's always good discussion. So.
Right. So here's an example of project number 1, where we did two kind of adaptive approaches. One is we had a large, we tested a implant, a comprehensive mock-up test similar to what you would do in a lab. And basically what we did was, because it was hundreds of miles away from our York facility in Pennsylvania, we brought the lab to the facility where they were prefabricating the panels. And it worked out well. And it may not have been possible 20 years ago when testing equipment was not portable. I mean, you can't transport a what was it, a B-19 bomber or something like that back in World War II. The fans are much smaller these days, and all the other equipment for measuring deflection and creating pressures are all portable. So we brought the lab to the plant, and the other one in the same project, we're going to be talking about how you do customized testing on special assembly. So,
yeah, so this was a unique project where it was fabricated at a manufacturing plant. So the quality is great. That's an unbelievable industry in itself, and I think, for a lot of buildings, I think that's a great solution. So that's the quality that comes out of those factories is pretty amazing compared to what you get in the field. So I'm not sure. I know that this particular company does a lot of buildings. It's not always brick; it's a lot of metal. But I think that it's a great thing to get if that's one of the options. I would definitely do it. It's real easy from a commissioning perspective too, to do site visits while they're building your panels and see them. It's a lot more cost effective than going to the job site and looking at a floor when there's wood and ladders and all kinds of stuff on here. You can go see all the panels. You can see 40, 50 panels in a day visit. So if you do that 2 or 3 times, that might justify a lot of, or you might find a lot of things in the factory that you can alleviate right away, and also give confidence to everybody in the project that the panels are being built correctly. So it's a great. I like this. We don't do it enough on campus, but I don't design the building.
It is the fabrication method of the 21st century, and your quality assurance is so much higher when you assemble the components in a indoor protected environment that you can actually build in the middle of, put together in the middle of winter. The gentleman there asked about weather conditions. This neutralizes the factor of weather conditions. You're installing sealant at the right median temperature. You're not putting sealant in the middle of winter.
Qualified people are doing the work.
Right, and you have qualified people, and they're working under the best conditions. So, and you're seeing, as Steve mentioned, products before they're installed in the field, and much easier to remediate then than afterwards.
And then once they show up, the construction site just takes off, right? You can put a floor or two every other day or something. It's crazy how fast the building, there's nothing, then all of a sudden you go by and 2 floors are up. And like, when did this happen? So it's pretty amazing. I like that, but that's not what this is about.
So just to show you an example, you can do a full-fledged wind pressure test, and we can turn on the slide here. It's pretty amazing that you can.
So yeah, that is a piece of glass that we're testing, and it was one of my first times seeing glass and it was liquid, and I'm like, what? I thought it's glass, and it didn't break, but it was pretty scary being around it for me from what I'm used to. So that was a good
we learned a lot.
eye-opening test.
We learned a lot from this mock-up.
Yeah. So this, needless to say, didn't end up in our building, thank goodness. But it took us a while to find out what the problem was, and it turned out to be a pretty simple fix that somebody didn't put in the right piece of glass for the mock-up. So even though you think it's all set, it looked great. We went to test it, and then when we took it all apart, a couple weeks, once they wanted to admit that something happened, so it was yeah. So
yeah, it's interesting. Even in the best scenario, they rushed the installation. They didn't give enough time during install and the fabrication of the IGU, and but. I can't highlight enough, and it's a sidebar discussion we can spend hours discussing, but the issue of glass deflection is a very important issue in terms of within the context of the performance of the building. And there's a lot of ramifications when glass over deflect, and again, that's another conversation, but I just want to highlight it is an issue that one should focus on your building envelope commissioning projects. In this case, no.
No, this was a mock-up.
Yeah.
Yeah, the question was, was this a piece that we tested, put in our building? And in this case, it was a mock-up for that purpose, to make sure so it's done way before the construction of the building. Again, we're probably a year before they started doing these panels. So the manufacturer was practicing building the mock-up to get their plant ready for us, because we didn't take their standard finishes and things like that, because we're special.
Yeah,
the architects always want something that's never done, so this was, and we can't say anything about that. We have to just let them do what they do. Hopefully there's not too many architects in here that do design.
One thing I will say, and it's not a joke, is that in terms of size and performance, one of the advantages of prefabricated panels is that if you think about how it's transported to the site, it's transported on a truck. And think about the seismic movement on the panel when it's on that truck. So one of the really good things is that most of those panels are already pre-tested for seismic movement before it's even on board. You can't do that with field install.
Some of them had to be repaired once they got to their building, but
that's true.
Yeah,
that's true.
But overall, it was good.
Not too complicated on those. That's true. In fact, the issues with this project has less to do with the joints between panel to panel, but it's between panel to field install components. And makes it easier to do quality assurance because you can just focus on those areas when you do your visits, because this is a engineered joint that is not the typical single seal weather seal that you see in buildings. I'm trying to advocate to a lot of people that we move away from that. But this is an engineer, double gasketed joint that is almost like a panelized curtain wall system where it just simply interlocks. And so the water just sheds right off on the horizontal joint.
Yeah, I have another question over.
Are there any concerns that the building is not built like the mock-up is built, or is there ways when you're doing the mock-up to help mitigate those differences?
There is concern about that. That's one of the reasons why we always ask that the crew that would install the panels on the building be the same crew that is
That does the
build the
mock-up.
mock-up. We don't often get that, and then what we're often our offer is that the lessons learned from the mock-up will be put into a quality assurance plan, and then that would be documented so that any person installing components in the field would be informed by that quality control plan and build it accordingly. But it is something that I think we can do better at, and it's something that MIT have been successful in getting contractors and making sure that the quality assurance control plan that was used to build the lab mock-up is used in the field. But it also points to the advantages of prefabricated panels, because that whole issue gets neutralized because it's all pre-built already and ready for installation.
Yeah,
the
and a
only thing
lot
you
of-
have to deal with is the panel.
And a lot of times it's hard, you know, the contractors will say we want the crew, and then, you know, because the building's done 2 or 3 years later, guys retire,
Yeah.
move on, go to other buildings. So it's kind of hard to guarantee that, but we hold the general contractor or construction manager responsible for incorporating everything we learned in the mock-ups, whether they're in the field or at the factory, to the crew that comes on board. And if they have to build another mock-up so they can practice as the crew, then they go ahead and do it. So, but that's a great question. So another example is that we had some canopies that we needed to install over our windows, and there was no test applicable for canopies per
Right.
se. So we had to.
If you think of a standard test assembly, the pressure is applied in a chamber behind the wall. This is a awning that's attached in front of the wall. There's no pressure that's going to be applied to that assembly. The only pressure you'll feel is during dynamic tests, and that will only get up to a certain level and test its weather performance. What we're looking at here is trying to do a structural test on this window that can demonstrate that not only is it designed properly, but as built in a mock-up, of course, that it will withstand the intended combination of wind load, dead load, and seismic and lateral loads. So we had we're scratching our head quite a bit between the OAC team to say, at one point we almost said, well, you can't test it. Well, that wasn't the answer.
We were going to leave it outside in the winter and let snow and ice build up and see what happens. We were afraid originally that ice would fall off them and land on the sidewalk and land on somebody or something. And then we started thinking about it a little more and realized the whole canopy could fall off the building. So it
Right.
made it a lot. It raised the awareness a lot more and the concern to the point that
the concerns was valid, and you know, as one of the members of the audience mentioned, the quality control involved in installation can affect your structural performance. And so we came up with 2 methods. One was, can we transform the combined uniform loads and to some type of simple point loads that can be imposed on the bracket. A bit tricky. And the other one we'll talk about later. But this is the first test method where we basically built a mock-up with just the brackets. Much easier. We didn't have to wait for the awning.
Yeah, we didn't have the awnings at that point.
So we just simply applied the loads. You can see on the diagram on the right, there are lateral loads, there are in-out loads, there are up and down loads. And the combination of loading during testing was carefully engineered with the structural engineer who was very collaborative.
Yeah, they approved of the numbers.
Yeah, they provided the numbers. They were very collaborative. It was reviewed by many. One of the things about modified test methods is you want a convergence of many points of view.
Yeah.
And this is the test result.
That's the
So we
results.
looked at it. It was astonishing that a 3/16 inch piece of aluminum would fail like that. The engineer was almost certain that it would pass, and it sheared. And we were really taken aback by that, and we realized, not just one of us, but all of us realized that perhaps the test method that we came up with, this test method A, didn't really simulate the conditions of uniform loading and the manner in which a uniformly loaded awning would impose loads on the bracket. So we decided to go with Plan B, which you'll see next. And Plan B was something that actually we engineered with the assistance of our Intertech lab colleagues in Pittsburgh during COVID 2020. Think about that scenario for a moment, and we'll get back to it. So the idea of this test B was that it would use balloon diaphragms and under pressure, and apply use the balloon diaphragm to impose loads on the installed awning. So in this case here on the right, it would be inflated and apply pressure outward onto the pressure. And then in the photograph, that's an illustration. In the video on the center, this is the other part of the test, is impose load from the outside. Well, that's a little tricky, but we built a transparent restraining wall that you'll see when we play the video, that kept the diaphragm from moving away from the awning.
Keep your eye at the...
Yeah, it'll happen very quickly.
Yeah, it happens pretty quickly. So
very,
the pressure's
very
increasing.
quickly, like right now.
And
It
deformed.
looks like a failure. It was not a failure.
No,
In fact,
that was actually really good.
it was a pass. The awning did not fail, and
It didn't deform as it got
we
to the
found
pressure.
a unique way to test awnings that I think we may start thinking about in the future.
So yeah, so that's just thinking creatively on what you could do to make sure that it's going to be successful on our building. But it took a long time, and we were happy that
Now,
that
this
we were
was
able to do it.
done in the middle of COVID 2020. I had already booked my flight, but Steve and I both did, to Pittsburgh almost the next day, right? The next day, both Intertech and MIT sent out directives to our staff. There was going to be no travel. So how do we manage to do the tests? We actually, as probably that video showed, we did the whole test virtually with videos, and we actually observed. The entire OAC team observed in real time, and actually was able to make comments on it.
And then we
in real time.
recorded it, so that's how I was able to
Right.
get it. So we were lucky. Who knew that we were going to have to do that for the next 2.5 years? That's another story. So yeah, another project. I just want to keep it on time. So we're going to
Okay,
go
I'll go
quicker.
quickly. This is how we transformed a visual mock-up into a fully functional test mock-up simply by building enclosing walls on the back that's highlighted in red, and a sidewall on the left there to prevent water from dynamic testing to sweep around and flood the curtain wall
That's
space.
a really small mock-up, and wait till you see how many tests we did on this mock-up.
Right. I'll just leave it at that. We'll see the other examples later on, just to keep the presentation going.
Was that? Oh, I'm sorry.
So this is
for us, the areas, the roof interface was a big concern for us, as well as the the interface between the curtain wall and the storefront here. So,
And this one involved a customized high-performance window that used triple laminated, a triple glazed laminated glass. So it was quite heavy.
Yeah, so these were some of the tests we did on the window and the AVB behind the brick. So it was a great mock-up. You know, I know we spoke about weather before. If you see here, there's a canopy on the outside here. This was done in the middle of January or February. They
Yep.
put a tent up that heated the outside of the wall, and we had a truck with water in there so we can spray water on it. It was pretty innovative of the contractor to do that. This is outside, and we were able to do this in the middle of winter. So
It was a great risk that the water would freeze if we hadn't done all these precautions. So it was very painful, and it was just one day. It was a painfully cold set of several days.
And of course, we had issues.
Yeah. Well,
The
in
one
spite-
window, non-operable, leaked.
Yeah, it was surprising. We did not expect that result. This was a prefabricated window, and it leaked. But nevertheless, it was very informative, and we learned a lot.
And it was great because we did it early on. So we took out the window, or not us, the contractor and manufacturer took out the window, dissected it, and found the root cause and fixed it. So none of the windows are. We didn't have leaky windows on our building.
No.
We had one in the test. They fixed it. We let it cure. We went back to the field and tested it. It passed. And then all the other ones, we witnessed the repairs done at the factory to make sure that all the windows had the same repair and the same step. They actually put together a book. I only show steps 4 and 5, but they put together a book of how they were going to fix it. And it worked. And we tested half the windows in the building because of this, and they all passed.
No.
So it was awesome.
This is one of the projects where we had the least number of failures.
And
in
everybody
the field.
stepped up, and it was a great process. This is
Right.
Yeah, it was really good.
But the remediation was really, the field test was really helpful because it highlighted something we assumed, all of us assumed was going to pass. And what they did was excellent analysis, and they actually provided a lot of redundancy in seals of the joinery, heel bead seals, and reinforced corner frames. And the window is installed and working just fine right now. So the second part
this
of
is
the
the
test,
same mock-up, just from a picture from the side angle. So.
We're testing.
You know, one thing,
storefront.
so we were testing in forefront. So again, you know, there were 5 or 6 tests before, and now we did 2 more. So in that one mock-up, we were able to do 7 tests, which is pretty good from our perspective.
Right. And we can show you how we operate.
Yeah, so
this.
one thing that, you know, we got fortunate with is that we brought in the dynamic fan, and it just fit within the spandrels of what the contractors had set up.
That's
So
an 8-foot
we didn't
fan.
plan that, but we literally had an inch on each side, and we were like, oh, and it fit. We were so pleased, but it wasn't something, but it's just every detail. You know, if you know what you're gonna do, we didn't even think about it. We go up and we're like, I hope it fits, and literally the boom truck had an inch on each side, so it was pretty scary.
So it's important when you do develop test protocols, you make sure that your mock-up can accommodate the test equipment. And we'll talk about another one where it cannot.
Yeah, again, it's full.
But we have
yeah.
to position the fan within 4 to 6 feet in front of the storefront. And it really worked well. Kudos to the operator of this lull, because he's a precise
And of course it failed.
technician. Yeah.
Right?
It failed in the area that I think we had always anticipated during peer review in the custom composite end mullion. That is not a standard product from the manufacturer. It was a built-up product of adapters and double mullions back to back. And we always had concern that we can't anticipate everything, but it is different. It's not a fully tested assembly within the manufacturer's lab test offerings. And we said, you know, we don't know. We're concerned. We like to focus on that. And sure enough, the test justified that.
Yeah. So then, you know,
Validated that
then we get the
concern.
reports and try and do remedial work and
Yeah,
continue to
it
try
leaked
and
in
do.
3 locations, I think you can see in the report. So we can see that the leaks occur in many locations on this.
We're just trying to
emollients.
troubleshoot it. But again, it's not on our building, so there's no big panic at this point.
Yeah.
It was great. Everybody worked together. We tested it and retested it. Eventually, we understood where the water came in from, and it was great. Everybody worked well. We learned a lot. The installers learned what they need to do in our building. So everybody was pretty pleased with what we found.
Yeah. I mean, there is a difference in story between the window and the storefront. Is the window basically passed on the second retest within a month and a half. This other one did involve several retests. It didn't just pass the first retest. It took a lot of iterations, but it highlighted concerns that helped us later on in terms of how to deal with issues in the field when we install the storefront. So this is a very interesting example of how do you test a remediation that is not per spec, not per drawings, with something, a solution for a problem that the contractor proposed, which in this case is a problem that resulted because of the construction tolerances. There wasn't the installed exterior sheathing with it interrupted the connection between the steel brackets, vertical brackets that penetrates the sheathing, and the connection to the hanger angles and the relieving angles for the brick wall. So several options, which we can also look at in the next slide.
Yeah, so one of them, at first the contractor said, hey, let's do this patch and put a sheet on and move forward. And then we're like, look how big that opening is and the risk, and compared to the final,
slide there.
This was the final solution. It was like an eighth of the size, and we're like, why should we make a 4x4 penetration when we can make a penetration
It's
that's
like 3
5
by
inches
34
or something,
inches, yeah.
So it was great to do it, but then again, now we have something that's not really per standard. So how do we test it and know that we're not going to have any problems? So again, we got creative and used some hose test and bubble gun test because it wasn't standard thing. We're like, hey, what makes sense? So again, we have to work with the contractor to make sure on the backside we can see things. Because again, you don't want to just spray water and have it go in the cavity and not know that it comes out. So be careful what you ask for and what you're trying to get. So always understand what you're looking for and make sure that it makes sense. Just to put water in a cavity and walk away from it might not be the best thing.
Yeah, we should pause on that a little bit. A lot of times, people see water entering cavities within the exterior wall assembly, and as long as it doesn't enter a building, they think, well, it's not a fail. Well, over long term, multiple freeze-thaw cycles, those things will become problems. They actually can become extremely serious problems. So over diligence is always a good thing when it comes to managing water. But in this particular case here, the key thing that we were testing is because of the unique transition, unique tie-in between the preformed silicon sheet that was proposed by the contractor to bridge the 1.5 inch gap on either side of that slot, that we wanted to assure the owner that the installed assembly will perform in terms of weather protection, because everywhere else in the building, the AVV was performed 100% perfect. We tested hundreds of, scores if not hundreds of test points on the wall. So what we did was we did a combination of using the bubble gun, which can fit within anything that can accommodate. I think I have my colleague here at Intertech. I think it's roughly about 18 inches in diameter. A nod would be good. Yeah, thank you. And but then what about the direct joint between the around the steel bracket? So what we did there, we combined that with a field test using a calibrated nozzle per AMA 501.2. And one of the things that what you must always remember when you do tests, make sure that you have the ability to view water penetration from inside the building. Don't have sheetrock in front of it. And the other one, make sure that location is accessible. Don't have it 3 stories up in a lobby and you're saying, well, it's up there, you know, how do you get there? You know, so that's one of the things we coordinated with contractors, make sure that we had ladders and can see it. But it luckily all passed and was very good.
So back to our project. So now you see this is on our actual building. And again, we did the mock-up test, so of course we did the field test, and it leaked.
Yeah. But what
And that is our building, and that was, you know, the same fan in the in our building, and that's the results at first. So, but we knew what it was, and it wasn't a big deal. They went back and just performed the same fixes they did on the mock-up, and it passed again. So
right, we knew that the concern was the interface between the metal fascia at the top and the complex geometry of the overhead.
you see,
roof deck.
that's the same test that we did at the mock-up. So there's no questions. We tested it in the. We knew what the results should be.
Right.
So it made it easy.
So it was self-diagnosed by the contractor. They deconstructed that area above the storefront. They remediated it. They did some isolation tests.
And then another side of that building had the same setup, and we were always worried about the roof. So we tested that again, and it passed. So that was good. We're going to have to go quick on this one, I think. Yeah,
sure.
We have 4 minutes. So this was another mock-up that we did at the testing site. We actually had all the contractors go there and build the mock-up right at the testing facility itself. It was huge. The glass was big, heavy. All the contractors went up there. They built it a couple weeks before we went out to test it. And we went through seismic testing. We try and use the assembly to test as many tests as we could do.
You can see it's a
So
whole
we
menu.
performed all the tests. We had the setup. It was done at the factory. So it took a long time. It cost a lot of money, but it was something that we had to do for our building. And, you know,
We
so
learned a
again,
lot from
the
this.
dynamic fan, we're inside the chamber over there. You can see some reflections of people inside. And
Sure
it leaked.
enough, it leaked. And we learned a lot. We learned a lot that as a field installed assembly using tube
So
mullions.
the one on the left here, you can see.
You can see the drops of water there. And then, luckily, it was actually fairly easy to diagnose too. It was a single point first order failure. A simple pressurizing the test chamber and putting smoke tracing
Yeah, it was a
on
pinhole leak
identified.
in some sealing.
So it's not
it
a
just,
systemic problem, it's a
Right.
very localized problem.
but we were glad that we found it. So now when it does go up in our building, we pay special attention to make sure that we don't have any of these issues.
The contractor took that to heart, and
Yeah.
we tested that window in the field, and both with hose tests and dynamic tests.
And then there's a bunch of slides with some bonus stuff that we're not going to get to.
Well, I guess we won't talk about this one. We can do that after the session.
But yeah, we're around
this
if
is
there's
a
questions.
fascinating
But yeah, so
case
you
study.
get some other, and of course, test leak, right? I'm going to end it. Well, yeah. But I'm always in shock, and I go and tell my boss, who's a mechanical guy, that 80% of building enclosure tests fail the first time, and he's in shock. And but it's just where we are. But I'm grateful that we do test and that we do fix it and move forward. If we didn't, so I can only imagine when I walk around and I look and see these buildings being built and nobody's testing. It's painful. So anything that we can do to stress the fact that we should be testing and fixing it before it goes in the building. Never mind the energy it saves. Never mind all that stuff. Just seeing what happens. It should just raise everybody's awareness. So thank you all for attending.
Yeah.